Hey guys, Mr. Middleton here. Today we're going to talk about surface areas of prisms. At the end of this video you should be able to find lateral area and surface area of a prism and explain the difference between the two. You should also be able to determine which surface area to find in a specific situation. Okay. Alright. So, let's get started. Prism definitions is a polyhedron with exactly two congruent parallel faces. Parallel faces. Okay, these parallel faces are called bases. The other faces that are not the bases are called lateral faces. Okay. The altitude of a prism is its perpendicular segment joining the bases. Altitude. Perpendicular segment joining the bases. Okay, and the height of a prism is the length of the altitude. So altitude and height go hand in hand when we're talking about polyhedron or prism. Okay. Okay, in this prism, what shape is the base? Okay, so being able to see where the bases are. Our bases, the two parallel, congruent faces here. Our bases are hexagons. They have 6 sides, so they're hexagons. Okay. What shape are the lateral faces? The lateral faces are the other faces, things that make up the sides, and those are all rectangles. Okay. And it's pretty easy to see because this is a regular, because it's a prism. We can see the height here. It's 10. All right. Now let's talk about some different areas that we will be able to find. Okay, the surface area. The surface area is the area of the visible surfaces. Everything that you can see. Okay. There are two types of surface areas. First, the sum of the areas of the lateral faces only is called the lateral area, and we'll abbreviate that with LA a lot. Okay, and the sum of the areas of the lateral faces and the bases is called the surface area. Okay, so you can think of lateral as the side, all the stuff on the side. Surface is everything on the outside, or everything that you can see or touch. Okay, in the example above, to find the lateral area, you would find the area of the 6 rectangular faces. And to find the surface area, you would need to use your lateral area and add the area of the two bases. Okay. Alright. Let the faces with the X's, I'll make them blue. Faces with the blue X's be your bases. Draw and label a net for this prism and then answer the questions. Alright. So, first, it says what's the perimeter of this base. Okay, well, we can tell what the bases are here. Bases would be here, these two bases. Okay, the perimeter of the base is going to be 4 plus 4, 8, plus 2, 10, plus 2, 12. Perimeter of the base will be 12 centimeters. The height, distance between the bases, is going to be 7 centimeters. Alright, so let's draw a net. That shouldn't be too bad to draw. It's a 4 by 2. 4 by 2. Okay, has a blue X. And then we have a couple of, let's do that on the first one. Okay, then we have a couple of rectangular faces. So we have 7. We have one right here. One below. Another one below And so we have another face. I'm just going to put it right here. Okay, so 4, 2, this will be 2, 4. Okay, and so we have all that labeled out. Write that there. Okay, so look at the big rectangle that makes up the middle of your net. What is the length of this big rectangle? Well, the length of this big rectangle will be 2 plus 4, 6 plus 2 plus 4 is 12. Its width would be 7, right? Because the width is here, 7. Just looking at this big rectangle, we could redraw it like this: 7, 12. Okay? So, what's the area of that big rectangle? Well, that area is going to be 84. The area of this rectangle is the area of all the faces except for the bases. So, this represents the lateral area, so LA. Alright? So, I showed you in the previous example to demonstrate where the formula for lateral area comes from. Okay, the lateral area for any prism is the product of the perimeter of the base and the height. Perimeter of the base and the height. Okay, so that formula for lateral area is perimeter times height. The surface area is found by adding the two bases to the formula. So in order to find the surface area, we say surface area will equal, well, that lateral area, perimeter times height, plus the two bases, area of the two bases. And so what does big B represent? It's the area of one base. The big B it represents. Okay, this shape will change from problem to problem, so the way you find B will also change. Okay, we've seen problems with a hexagon, we saw with a rectangle, and below you see some with triangles and hexagons. You'll see different shapes, and we've encountered these before, so we'll just have to kind of review that as we go through. All right, so first problem, we will need to find the lateral area and surface area of each prism. First problem, we have a triangular base. Triangle, okay, is the shape of the base. And so we're going to find the lateral area. Our lateral area, remember, is the perimeter times the height. So the perimeter of the base times the height. And so this base, we have a triangle, 3, 4, right triangle, so we can find this by using Pythagorean theorem. Or you can just remember 3, 4, 5 triangles. And so the perimeter of the base would be 12. The height of the prism is 8. And so the lateral area is 96 feet squared. All right. In order to find the surface area, what we're going to do is we are going to take the lateral area, kind of the same thing, plus the two bases. So 12 times 8 plus 2 times, okay. Now the area of the base we haven't found yet. Okay, we need to find the area of the base. I'll do that up here. So the area of this base is going to be 1/2 base times height, right? And so we're talking about this triangle. In the triangle, 1/2, 4 times 3. 4, that will give us 6. Okay, so we see that the area of the base, and I'll just write capital B here to hopefully avoid any kind of confusion. The area of the base was 6. Okay, so 12 times 8 was 96. That was the lateral area. Now we're adding the area of the two bases together, and so the surface area will be 96 plus 12, which gives us 108 feet squared. Okay. All right, next problem. We are dealing with the hexagon now. Hexagonal prism. Hexagon. Okay. And so, same kind of thing. We need to find the lateral area, perimeter of the base times the height of the prism. The perimeter of the base is a regular hexagon. That means all the sides are the same. So 4 times 6 will be 24. The height of the prism is 10. And so the lateral area is going to be 240. 240 centimeters squared. Okay, in order to find the surface area, we need to add the area of the two bases. Now, it's a regular polygon. Remember, we can find the area of regular polygons by 1/2 apothem times perimeter. And so we'll need to find that apothem, or apothem, however you like to call that. Alright, and so what we're going to do in this hexagon, this is 4. We know that this central angle would be 360 divided by 6, which gives us 60. We cut it in half so we can look at the triangle. That gives us 30, 90, 60. So we have a 30, 60, 90 triangle. With the base not being all 4, it's going to be 2. So if this is 2, our height then is 2 radical 3. This is 4 if you remember your 30, 60, 90 triangle. So that helps us out because now that height, remember, is the apothem. So we can find the area of this hexagon by saying 1/2 2 radical 3 times the perimeter, which is 24. Okay. So that means our area of one base will be 24 radical 3. Alright, now that helps us because now we're going to use that for our surface area problem. Surface area, remember, was the lateral area plus 2b. We already know our lateral area is 240. The area of the base is 24 radical 3. And so we have 240 plus 48 radical 3. Now we'll leave our answer like this, centimeters squared. If they did ask us to round to the nearest tenth, then we would be able to do that. But writing the exact answer should mean that we're able to take it to any decimal place that they ask us to. Okay, so anytime directions aren't clarified, I usually like to leave the exact answer. Okay. All right, so let's go through kind of a real world example. An above ground pool is in the shape of a regular octagonal prism. The pool is 5 feet off the ground, and each side of the pool is 8 feet long. How much material do I need to make the walls of the pool? Okay, so we're thinking about a pool. It's octagon. Not very good at drawing these things, but I'll try. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So, octagonal prism should look something like this. Dot, 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 dot. Okay. Alright, so as we draw our sides, we know that this height is 5, and that each side is 8 feet long. Okay, sweet. So now we're going to do the same thing here. First of all, we need to find out what we're finding. It says how much wood is needed to make the walls of the pool. Now we're talking about the walls of the pool. We're talking about just the sides. So when they're saying walls, we know that means lateral area. So the lateral area is going to be the perimeter of the base times the height of the pool. So the perimeter of the base, well, we know each side is 8. There are 8 of those. So that gives us 64. The height of the pool is 5 feet off the ground. And so 64 times 5 gives us 320. And so you need 320 feet square of wood. Okay, realize that this does not include the top, because you wouldn't want wood to cover up the opening of a pool, and doesn't include the bottom because it's not a side either. Okay, so it says, what is the area of the lining on the inside of the pool? Okay, now you have to think about this a little bit more, because yes, we talked about surface area and lateral area, but this isn't necessarily asking for that. It's asking for us to think a little bit more than just plug into a formula. The lining of a pool. does it go over the top of the pool? No. So, while surface area will ask us to find the lateral area plus 2 bases, we know for this problem, the lining doesn't ask us to cover the top base. So to answer this problem, we're going to say, okay, it's going to be whatever the lateral area is plus the area of one base. Okay, so let's find the area of one base. 1, 2, 3, 4, 5, 6, 7, 8. This is 8, okay. Probably going to need a calculator here if you don't have one out by now, like I don't. Okay. All right, so as we look for our triangle, because this is a regular polygon, so we're still using 1/2 the apothem times the perimeter. We know the perimeter is 64 already, but we don't know the apothem. So we can find that by 360 divided by 8. That will give us our central angle. So our central angle is 45. And then we have to divide that by 2 to find this angle, which will give us 22.5. Okay. Now this whole side was 8, so we're going to use this side 4. Okay. All right. So now I want to find this apothem. Opposite, adjacent, that means I'm going to use tangent. So I can say tangent of 22.5 equals my opposite over adjacent. Does that work? Okay, and so now I can find adjacent by multiplying both sides by a and then dividing both sides by tangent 22.5. And so I'll get a equals 4 over tangent 22.5. So now I can do that on my calculator, make sure it's in degrees. 4 divided by tangent 22.5, 0.5. And that gives me 9.656. Okay, so that's my apothem. I am going to just leave it in there and do my math. So times 64 times 1/2. I know the area of one base is 309. Okay, so area of the base is 309. If I were going to round to the nearest tenth, it would be 0.0. Okay, plus the lateral area that we just found is being 320. So plus 320 gives us how much lining we need, and that's 629. 629 feet squared of lining to cover up that pool. Okay, so there you have it. Using lateral area and surface area to be able to do that with prisms. All right, see ya.